Go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Welcome, ladies and gentlemen, to Making Data Simple, or as Tim Ferriss would say, ladies and germs. I'll give you 3 quotes for today. Number 1, the people who are crazy enough to think they can change the world are the ones who do. Steve Jobs. Another quote, it always seems impossible until it's done. Nelson Mandela. Third quote, barbecue may not be the road to world peace, but it's a start. Anthony Bourdain. Given I'm from Kansas City, where we have the best barbecue in the world, you know which one I'm going with. Number 3 is the best. That's how we'll save the world. Barbecue. I'm going to jump in. And today's topic brings us back to data and founding tech companies, but data as well. My guest today is Rohit Choudhary, who's the CEO and co-founder of Acceldata. Let me introduce Rohit a little bit here. He's developed a multi-dimensional data observability cloud that'll help enterprises observe and optimize modern data systems and maximize return on data investment. Prior to Acceldata, Rohit Choudhary served as Director of Engineering at Hortonworks, where he led development of data plane services, Ambari, and Zeppelin, among many other products. He's passionate about big data, so we have a lot in common here. Rohit, welcome to the podcast. I appreciate you being here.
Thank you so much, Al. It's a pleasure to be here. In your sequence of quotes, I would also like to add a quote. They said, don't give up on your dreams. So, I just went back to sleep.
Very good. That's a good one. You beat me. Thank you for that.
Indeed.
Very good. Again, thanks for being here, but please share your bio in a bit more detail if you would.
Yeah, of course. Like you mentioned, I'm the founder and CEO at Acceldata. I've been running this company for nearly 4 years now. We are in the 4th year. Started in 2018 with a bunch of really good friends and co-founders, all from Hortonworks. My journey in doing startups has been, depending upon where you put the reference, it either started in 2018 or it started in 2008 when I joined my first startup. That was in Mobi a long time ago. Mobile was undergoing a revolution. I'd seen a bunch of my friends carry the iPhone late in 2007, and in 2008, early when I got an opportunity to jump into a mobile advertising company, I knew that the future had arrived. So I just joined over there. Worked a lot over there in, ad networking, understanding the paradigm of advertising, learning how data would scale in the years to come. And ever since just got hooked. So everything that I did after that was in and around data. 2014, I think, towards the end, I started getting the opportunity of working at Hortonworks, and I just felt like a kid in a candy store. There was so much to do with data, so many different projects, all of them coming together in one big data platform. And just look at what happened in the world. So, I continue to be fascinated with what's happening with data and so excited to be in this industry.
Yeah, data for me. It's making data simple, right? That's why I've never changed the name, even though we talk about leadership and everything else, because in one form or another, it always surrounds data. One thing I read about you is that it said you were inspired to start Acceldata after repeatedly witnessing customers' multi-million-dollar data initiatives fail, despite employing the latest technologies and having the best data experts. Is that true? And can you say more about it if it is? I presume it is.
Absolutely. I think, if you think of what companies are trying to do with their data is to get value out of it. They're trying to get all of that data that they've collected over a period of, 20, 30, 40 years into some kind of operational structure so that they can determine the best use of their data, apply it to different use cases, delight customers and all of that, right? So that's great. That's the intent. One of our customer execs, recently called me and said, what's happening? The world thinks that everything is a Hollywood movie, and, Bruce Willis and the young guy who were in a car, in some Die Hard 3 or 4 version. And people think that everything is going to get done in the next 15 minutes with a kid with a backpack and a keyboard and a mobile internet connection. The challenge really is that it's not that simple. So if you talk to any serious data leader today, they essentially have a multi-generational technology sprawl. They've got mainframes, they've got Teradata, They've got different kinds of relational databases. They've got Salesforce, Oracle ERP. They've got Hadoop in between, and they're now selecting between Databricks and Azure Synapse, and you name it. So the real challenge is that where does data become useful? Is it going to become useful in all of these different versions, or is it going to come together in a data lake? Is it going to come inside a data warehouse? How are you going to use it? And that was sort of the unique insight that we had in 2018, that every time that I spoke with a customer, they would say that you guys have given us the platform, but I don't know how to use it. I don't know what to do when something goes wrong. So what we figured out was that whether it is data and analytics, whether it is machine learning and AI, custom dashboarding, reporting, any of these use cases take a lot of time to develop. The constituents of the whole data ecosystem in general, they have very, very different requirements, and it's very difficult for the data team to satisfy everyone's requirement. So I think we saw the opportunity over there, and that's how we started. And the core hypothesis that became for us to start was everybody was going to become data driven. Everybody will have more and more complexity attached to it, and there are not enough talented people. So anything that you can do automatically with observability and automated actions would become a big thing.
Now you're the CEO. How technical are you? Are you a technical CEO? I mean, are you in the trenches? Are you coding, or are you running a business?
Yeah, so my code has not hit production since 2019. So it's been 2 years that
Well,
my code.
2019 is not bad. That's not too
Yeah, it's
long
not
ago.
bad. Yeah, it's not too bad. And I still write my own scripts and try to figure out, what's going on within the organization. I try to keep an eye on, what are the projects that are, getting popular within the communities, trying to figure out, who has applied what kind of logic. It's really important. I'm a product-led CEO, so for me, it's really important to be in touch with the realities of the world. And tech is moving really fast right now. So if you're not keeping in touch with what's happening in the world, I don't think you have a good position. You're in a good position to sort of win this market.
You were at Hortonworks prior to the acquisition
I
of
was,
Cloudera.
yes,
Yeah. So you
that is correct.
left. Well, you left before the acquisition, then,
And I
right?
left before the
Yeah.
acquisition, indeed.
Is Hadoop still a future player? I mean, is it going to be a future player 5 years from now?
Yeah, I think it's tough to comment on that, but I would say that the net value of that stack eventually will decline. There's no doubt about that. The only pattern that people keep reminding me is that everybody said mainframes were going to be out, and they never went out of fashion. Now, as true as that sounds, it appears that the equivalent data processing paradigms on the cloud and through the ISVs, they're actually getting better and better. So with every passing day, we are seeing feature equivalence, more comprehensive availability of data compute platforms on the cloud. And it could be argued that over a period of time, cloud is going to be the future. Now the question really is, or the contention really is, that is cloud as cost efficient as on-premise Hadoop data lakes? And I think that is probably the last question that people need to answer. If that is answered well, I think we are looking at a wholesale migration towards the cloud.
I mean, you compare it to mainframe. When I think of mainframe, look, I'm an IBM, so yeah, they're still running very, very, very strong. It's almost like a car. That's a lot of people think, oh, mainframes are legacy or something. Are you kidding me? It's like we don't call cars legacy, but cars were what manufactured on the line like around 1916 or something like that. I don't know. I'll get that wrong, but and we just continue to improve them. The same thing with the mainframe. I think the first mainframe maybe in the 40s. IBM's mainframe I think was around 1964 or something like that. But Hadoop, it hadn't been around near that long, and does it have the traction that you think it needs to survive in the future?
I think the real question over there is it mission critical enough? Mainframes are, and therefore they survive. I think most of the system of records, transactions, everything that banks do today, it's based
Hmm.
on a network that's backed by mainframes. I don't know if Hadoop is powering all the mission critical use cases. I think it is certainly to a large extent powering extremely large, data companies, whether it's banks, financial companies, financial institutions, credit card companies, hospitals, healthcare companies. Everybody is using that for serving mission critical use cases. I think if the mission critical use cases continue to be there, which is in line with the philosophy of Hadoop, that you can bring in structured, unstructured, different kinds of data, process that as quickly as you can and as efficiently as you can, and then still get your batch and real time reports, then if that's the use case that you're looking at, I think that's going to continue to function. If you're and there's the fundamental truth as well, which is where are the applications right now. I think we are entering into the early phases of a decade long journey into the migration of cloud. And there's going to be different phases and different kinds of applications which will move to the cloud to begin with, and therefore the associated data, and therefore the associated eventual data compute platforms. So I think it's going to be a sequence, not one after the other, or not all at once. Will be a sequence in some kind of order.
Makes sense. Makes sense. Thank you for that. Excel data been around 4 years. Why the name Excel data?
To just accelerate the success of data of your organization. This was
So
precisely the problem that we wanted to solve, that ROI is so backed up. It's almost like, supply chain and COVID. If you really want to make the supply chain of data work effectively, then you need to watch it as closely as possible, because it's so precious. And so we felt that, Excel data would be the right name for this company.
makes sense. So you're driving the concept of data observability,
Hmm.
and that data has to be managed in a multidimensional way. Can you say more on the meaning and definition of data observability in your mind?
Yeah, of course. When you think about data observability, it is about, looking at data slightly differently. The first thing is that you need deep insights and cross-sectional visibility. Now, what do I mean by cross-sectional or comprehensive visibility? It essentially means that you're able to monitor the supply chain of data. And the supply chain of data has three key elements. One, the data pipeline itself. Now, data pipelines are being constructed by data engineers day in and day out, which are essentially, you could call them, from the old paradigm, as ETL scripts, but they have actually evolved to become so much more these days. So essentially, it is about connecting the data which is generated at the point of origin and tracking it all the way to the point of consumption. When you deliver this data from, the point of consumption to the, point of, or, point of origin to point of consumption, you need to make sure that the reliability of data can be verified at every step, that the pipeline defines, whether it is about, loading data from different sources, transforming it, or doing something with it, enriching it, and eventually taking it to consumption. And the final thing is the third layer, which is the third stack of it, is that, the infrastructure that you run it on, whether it's a Spark engine, whether it's Spark on Kubernetes, whether it is, some cloud data paradigm, that runs efficiently. There should not be any latency, there should not be any performance gaps. So if you can guarantee the quality of data, if you can guarantee the quality of performance, and if you can guarantee the SLA of the data pipeline, then, your business process is accurate. I can give you an example. If you're running, let's say, credit card fraud check algorithms, 10,000 times a day, you want to make sure that that pipeline or that business process has exactly run 10,000 times a day, within the same limits of performance, with the same level of quality of data, without any drifts in data, without any drifts in schema. So it's really important to think about, data as a concept of a domain, which represents a business process or function, and all the elements that will necessitate its accuracy, that needs to be monitored. So that process is called data observability.
Could you repeat the three layers real quick, though, for the audience?
Yeah. So data pipelines, data reliability, and infrastructure compute. Those are the three layers.
Which layer do you think is the most troublesome?
Depends upon your journey. So, if you drew a capability maturity model for an enterprise, they
Mhm.
go through different phases. And some of those, some companies are very early in their journey where the infrastructure and compute troubles them a lot. You're in the process of definition what you need from your data, which is, commensurate with what you're trying to, selection of technology, adoption of that, learning that, the team is continuing to learn that. So infrastructure and the pipelines, they go in parallel. And then data reliability then becomes an ongoing problem. Now here's the wrench or the curveball. As your data volumes grow, the infrastructure and the pipelines, they start breaking, because you had built it with assumptions. So, there's like a phase of stability, there's then a phase of instability, and then there's stability. So it's almost like a sinusoidal curve.
Where does data cleanliness fit into these categories?
Reliability reliability. What is really happening is that industry, if you just think of the backdrop of what has really changed, the volume of data that has gone up, but it's gone up by like 100x, maybe even 500x. Companies that were generating, 10 terabytes of data a year are now generating, 10 terabytes of data a day. So that's just completely blown up. They've gone up like by 300 times in terms of just the data volume. And the other thing that is the big change, which I don't think enough people recognize and talk about, is the lack of structure. So if you went back, 20 years back, you had all the data that you had in your data marts or data warehouses. Everything had a structure. It had a definition. It had a name called customer. It had, a derivative called, customer reports or customer name, customer marketing, customer advertising. All of that had structure. There was like some merit to the definition of that. But today, what's happening is that, newer sources of data come without any definition. So the schema is no longer on write. The schema has become on read. So I could just start sending you a new feed, and if you're basically the recipient at the data lake, it's up to you to figure out what am I sending. If you look at the large data companies which sort of are responsible for, let's say, providing insurance underwriting data, if they're responsible for providing trade related data, they're dealing with 50,000, 100,000 different sources of data of the definition that they have tried to define as best as possible, but the cleanliness of that is not their guarantee. So the volume has changed. Now, with such volume, your compute comes under pressure. So you need more resources. If you're on the cloud, it'll cost you a lot. But what has really changed is that people are now making decisions off this data in real time, because all these data sources, all these processes have been sort of operationalized. So when you're trying to put all of that data into action, what you have really is the risk of having unreliable data outcomes. So if you were the CDO, if you were the SVP of engineering, and you were trying to get better results out of your data and analytics initiatives, then you would basically be worrying if that data was unclean, and if you were going to make unreliable decisions based on unreliable data. So it's become really, really important.
Well, so that's why, I mean, you're talking my language here. I mean, in terms of, I figured it was going to go into the reliability category. It's hard to find one source of the truth when we're talking to data. And on this podcast, quite frankly, we talk about it all the time. But the question is how do you solve this problem? Because it's almost like the tech world is going the wrong way in that you got no SQL database, you got no schema databases. I think you were mentioning this. So developers love it. They can just develop, get started quickly, but then before you know it, you've got a mess to clean up. How do you solve the problem? How do you
Yeah.
keep the data clean?
Well, first of all, you've got to get control of the map that is visible in front of you. Like I was telling you, some of our executive sponsors, they essentially are dealing with the Pivotal Cloud Foundry, Azure, Hadoop, relational databases, all of that together. And it's not even just the lack of structure. It's basically about harmonizing structured data and unstructured data. And that's where most of the pain is coming from. I think things are definitely better than how they were 5 or 6 years ago, because way back in 2015 or something, you would only have 5 customers who were extremely successful with something like Hadoop. But today, if you just look around the room, I think the Fortune 500 have figured out. I don't think, the top 10,000 companies have figured it out all out. And I definitely think that, developers are still required, in this modern age. And I think that is putting a lot of constraint in terms of who's eventually going to win with data. If you look at Facebook, Apple, Google, any of these large hyperscalers, because they have the ability and the access to talent that can deal with the complexity that's arisen, I think they are at a bigger and bigger advantage. With every passing day, I think they are at a bigger advantage, because they can figure out, understand the insights that the data that they've collected is providing them, and they're doing better. I think the first thing that people need to realize is that there's going to be a centralization. There's going to be a centralization of selection of technology, the ownership of people, and the ownership of data delivery. And if you put all of these three aspects together within a centralized function, which also owns its own IT very, very independently, I think you're going to meet with more success than failure. First of all, second is, I think a lot has been said about what data catalogs can do and cannot do. I think catalogs are an interesting concept, but they're just the beginning of the journey. But I personally believe that catalogs have literally failed the data and analytics industry for the last 40 years. So what you really need is an active management policy, which essentially is something that observability is trying to bring to this whole industry. That we know that I'm going to ask you to take a very, very complex journey from San Francisco to New York, but I'm not even willing to give you the navigation map. And I feel that getting active in the process, trying to figure out what our critical data elements are, what are the critical workloads, where is data moving from, what are the interconnections between two systems, as opposed to just looking at it within the system boundary. I think some of those key elements will be really required to be figured out before you meet with outside data success. And unless you do that, I think it's going to be the ROI is further pushed out, maybe by 2, maybe by 5 years.
Great. Thank you for that. So let's talk about Excel data.
Sure.
What's the technology behind Excel data, and how does it differ from what we see in the market today?
Yeah, so let's draw two reference points. If you go back to the previous generation companies, which were doing observability or are doing observability, monitoring something which is very, very defined. So, for example, user takes an action on the browser or the mobile application, a request is initiated, a workflow is triggered. That workflow has 10 to 15 different steps. Those steps get over, and you've monitored the whole thing. You're implementing Oracle ERP, you're basically setting up a workflow and a process, and you're monitoring that. So that's like the previous generation of companies where you're sort of automating manually defined processes and you're trying to put IT into that. Circa 2020, what's happening? We're collecting, all of us are collecting a lot of data. We are large enterprises, we want to delight our customers, we want to do recommendations, we want to do next best action, we want to be predictive, preemptive, all of that. So what's really happening? We don't know what do we have in our data, because there's no structure. So there's no table which says, in my data warehouse, which comes and tells me that, hey, here are the predictions that we can list down for our customers in the next 15 minutes. None. There's nothing. We've got to figure out what are those hidden insights in the data that we've collected over the last 5 years. And what you end up finding is that all the tools that you apply to identify those insights are extremely rudimentary. And so you start finding those. Now, as you find out those insights, what you see then is that those tools are, either failing you because they are not stable, they are built by a community and you've just adopted a version of it, or they are not performing as accurately as you should, or as they should because of your changing volumes. The third is your own demands from the business consumers and everybody that changes. So the first thing was to recognize that this is a very, very ambiguous space to sort of enter into. So the first thing that we did was that we identified what are the different compute models. How does streaming technology work, how does large scale data processing works, and of course our background helped in all of that. And we try to figure out ab initio through first principles that what are the different changes. So for example, data reliability is not about just going and monitoring a few databases and saying, okay, we're good. Data reliability is now about understanding petabytes of data and saying 50% of these rows don't make sense. So I think fundamentally what we had to do was to completely rewrite the technology. We had to break all the previous assumptions and deal with a lot more ambiguity in this space. Some of the other companies which were created in the 2019 and 2020 timeframe are essentially also trying to do some similar things, but they're also only tackling the area of data quality. So I think we are fundamentally different. Now, the key components that we look at ourselves as that, first of all, we need to be able to process different kinds of data at a very, very different kind of scale. As an example, we get signals from the infrastructure layer, from the compute layer, which is Spark or Hive, or any of the SQL technologies that you're using, or Kafka. So we get data points and metrics at a velocity that we've not experienced in the past. You get data reliability constraints, which is metadata, SQLs, user information, and everything. So therefore, you need a correlation engine which can correlate all of these different metrics at a level that all of these information pieces then become actionable for operators, data engineers, and executives together. And of course, the way that we thought about the technology was that there's going to be a range of different kinds of users. So the most technically adept will integrate with this programmatically, and the least ones will probably want to consume all of this data in a very, very self-serve UI based fashion. So all of these elements had to be recreated.
Do you work with any corpus of data? I mean, can it be Hadoop? Can it be data warehouse? Can it be OLTP? Doesn't matter.
Yeah, yeah, absolutely. So today we support OLTP databases, we support cloud data warehouses, all of those technologies, and including Hadoop. But the key thing to note is that we're focused on unstructured data, where most of the problems are today.
Unstructured data. That makes sense. Are you hybrid? Can you go across different corpuses of data in different clouds?
Yeah. So that was like one of the fundamental assumptions of ours, that it's always going to be a multi-technology and a multi-generational sprawl. You go to any enterprise, and since we're focused on the enterprise, we were very clear that the multi-generational technology sprawl is not going to go away. And any enterprise today which is trying to sort of figure out a strategy which will work for their data, most of the times you'll find that they have at least two clouds in the mix.
So, give us a description of your typical engagement, how it works, where it starts, how you're engaged.
Yeah, so it's very interesting. One of our first customers was GE, and they essentially wanted wing to wing visibility. Their whole vision was give us all of it and give us now. So we started working with them. A lot of our vision has been developed with customers. We're always customers first, because
Mhm.
customers are at the bleeding edge of sort of innovation in a different way, that while the Facebooks and the Googles have shown the path, some of them decide to walk it. So we work with customers very, very clearly, trying to identify and understand what are the key challenges that they're facing with. Incidentally, our second customer, they were essentially a hyperscaler in India. PhonePe has about 300 million daily active users, and last year alone they processed about $700 billion on their mobile app platform, which is approximately of the size of 17% of the economy of India at $4 trillion. So it's a pretty significant undertaking. For them, the biggest challenge is that their infrastructure, which is the OLTP databases, the OLAP databases, and the streaming systems, they cannot go down. So system reliability is like the number one concern for them. So we actually started working with them at the infrastructure and compute layer, which is a pulse-led initiative. When we started working with them, they only had about 70 nodes, and today they are at about 1,700 nodes in less than 2.5 years, and they've just ramped like anything. They were like in a bit of fight with Google and another Berkshire Hathaway company called Paytm, and they beat them hands down. 50% of the market is at PhonePe, and for the last 2 years, they've experienced zero S1s. Their systems have been absolutely reliable, and that is something that we bring to those engagements. When we Another example that I want to give you is about Verisk. We started working with that company about 6 months ago, and they wanted end-to-end visibility into all their data pipelines. And they are essentially the provider for all the underwriting data for everything that happens in the US from an underwriting perspective, whether it's State Farm or any other company. And they needed visibility into the reliability of their data. So we started at the data reliability layer, and that engagement has been going well. So what we did was we thought of the whole cloud as a set of capabilities of feature families, and depending upon where the customer has the most pain, like I mentioned earlier, advanced customers will have issues in their data reliability layer. Early customers will have issues in their infrastructure layer, and really advanced customers will buy all three. So we sort of make sure that the solutions are independently selling as well, as opposed to just the platform.
Are they running all your software, or is it mixed between different software, or is it mostly you guiding the implementation of their software?
So we essentially have a self-serve version as well, so that you can download the bits, deploy it in your VPC, or sign up for a cloud and start working from there. And we give you a version of that. The implementation is fairly straightforward. So for us, like I was telling you earlier, if you're basically a customer with, let's say, 1,000 nodes, and you wanted to install infrastructure and compute visibility, we'll be in and out in less than 7 hours.
Makes sense. Your first example with no downtime, I presume that was in the infrastructure layer. Was
Yeah.
that a matter of just adding redundancy or what?
So it was actually about adding visibility. So this is the most common example that I give to everyone. If you had a small kid in the house, let's say a toddler, you'd always watch him. Data systems are just like toddlers. They are going to basically they're going to break all the time. They're going to try to do, try to go into areas that you don't feel comfortable with, and therefore you've got to keep watching that. So reliability is nothing but operating at a level with a visibility that is telling you the real-time status of all your systems, all your services, all your users, all your workloads. And if you get the advanced information, let's say if I know that I'm going to have an outage 12 hours later, then I've got a lead or a jump of 12 hours on the problem, and therefore I won't let it go.
Do you have AI built in? Say more on your implementation of AI.
Yeah. Yeah. So we actually did a lot of, predictive implementation. So the first thing that we did was to basically, look at ML principles. First thing that we do is we analyzed all the different data. Like I was mentioning to you earlier, that, we collect all the data that comes into, the system at different velocities. You get metrics from the infrastructure level, the compute layer, the data level, the metadata, user, all of that. And then you start harmonizing that. You basically say, okay, here is the feature family that I'm going to go create, and these are the weights that I'm going to assign. So the first thing that we did was that we started identifying anomalies. And once you start identifying those anomalies, then going and predicting when you will run out of capacity on a something. Now, the number of times that we compute these predictions depends upon the frequency of usage. So, for example, if it's Kafka producer or a consumer topic, which is extremely heavily used, then we can tell you that the rebalance is appearing in the next 48 minutes. But if it's just cost, we can compute it once a day and send it out to the exec or the CFO who's sort of responsible for making sure they don't run out of money.
Makes sense. So you've done well in a short amount of time. I know you tell me if I'm wrong here, but I know you have GE, you've got Walmart, you got Michelin as some of your early customers. How did that develop? Is that more of a co-development type of thing? Is that how you get in? I mean, is your technology just wow them? Is it a little bit of everything? I mean, how did you secure some of those large customers so quickly?
Yeah, it was very interesting. The early customers, GE and PhonePe, which is basically the Walmart company. I think they enabled us to actually get a real peak. Now, while we had our own ideas, coming from Hortonworks, and we understood real-time production environments and batch production environments really well, I think there was definitely an element of collaboration with our early customers. In 2018 and 2019. By the end of 2019, we were pretty sure that our infrastructure and compute layer was coming together very well. So 2019 onwards, I would say Q4 2019, we didn't have to worry. Pulse started selling on its own. So we are these days, we do contracts in less than 4 to 6 weeks, which is amazing. At an enterprise scale. On the data reliability aspect, we launched the first beta version in 2020, late 2020, and GA'd in Q1 of 2021. We're still learning on that, because that space itself, data management and data reliability as a space is just way too big. It's all you could almost say that it's the Wild West at this point in time. Everybody has a version of everything. Somebody has a DQ tool, somebody has a governance tool, and there's the other thing as well, that some customers see this problem and some are just getting to that, which is that they are unable to put their finger on where the problem is. So it depends upon the maturity of the customer as well, because while we would like to work with everybody, I don't think everybody works with us right now, in the sense that they don't have greater than 100 terabytes of data. They don't have 5 different systems, and they don't have a fully fledged function which takes care of data. And in the absence of those three, we don't feel we are the best partners.
Expand on that a little bit more. So you believe, or you're really tailored for large corpuses of data, like 100 terabyte or more.
Absolutely, that's the best place for us to be.
Does that mean you anything less than that it doesn't work, or is it just not as optimal as you'd like to see it, or the value prop isn't quite sustained?
The environment is not as complex as where you would basically apply the principles of observability. Now, it may so happen that you may need one layer of the solution. So if you're, let's say, at a 10 terabyte you know data warehouse and you're worried about data reliability, so absolutely, you could use the solution. But if you're looking at full-fledged monitoring, optimization, and understanding of your data pipelines, of your infrastructure and compute and data reliability, then you'd probably be above 100 terabytes. And like I was mentioning earlier, companies, enterprises that have this level of complexity, they get to about 10 terabytes or 5 terabytes of data almost every day. So it's almost like a fully intersecting Venn diagram, that you have the complexity and you have the volume of data.
Does your technology then prevent future issues with reliability infrastructure? I mean, does it anticipate?
Absolutely. Absolutely. One of the first things that we did, like I was mentioning earlier, that, we created these different interfaces, that all the way from self serve to programmatic implementation. And if you want to be really preemptive, one of the biggest shifts that we are seeing in data reliability is that people don't want to wait until the poor outcomes have been achieved. So, what people are really trying to do is to shift left. They want to eliminate the data risk. And by that, what I really mean is that the moment data has landed in your raw zone, before it heads into your cloud data warehouses or your data warehouses, you'd like to, clarify as much of that as possible. You'd like to clean that data. You'd like to make sure that you can make good business decisions based on that data. And that element of shifting the risk towards left is what is the biggest change. So if you think of, how do you prevent that? You essentially integrate with the APIs. So as you're writing your ETL processes, as you're writing your orchestration tools and using different kinds of compute paradigms, such as Spark, such as DBT, such as Java, you can insert those APIs and make sure that as you're processing your data inline, you can both call synchronous blocking and asynchronous non-blocking calls onto the data quality. and make sure that you're able to get the answers before that data goes and hits the data warehouse or the eventual point of consumption. And the more you do it in advance, the better it becomes for you. And over a period of time, what ends up happening is that you're enabling your developers to go and use all of these APIs, provide them with standard services as opposed to letting them build their own. You're able to standardize for the rest of the organization.
Where do you think you guys will be like 3, 4, or 5 years from now?
I think we'll be a fairly large company with uh, the leadership in the space, and we would have educated the market about data observability sufficiently so that everybody knows that this is the thing, this is the missing layer of the data stack that they had been wanting for such a long time.
Where do you get most of your OI, your identification, your opportunities? Where do most of your clientele come from?
So it's interesting. We've got a mix. We basically have our own sales force at this point in time, and we've got a fully fledged, fully functioning marketing team as well. So
Mm-hmm.
we've got both motions, which is outbound and inbound. And we also have some really good partners. Some of that includes, companies like Kyndryl. We are partners with them. A lot of
Mm-hmm.
partnership opportunities are coming from there. A lot of references are coming from there. We are also partners with, large consulting firms. And so what we're seeing is that there's like a tremendous interest in some of these partners also to go build practices around our products, because our products are required for data operations anyway across the companies. So if you have a customer and you want to basically provide them with better data ops, you can use our tools and platforms. We're also seeing a lot of interest from the cloud players as they are trying to complete their offerings for their customers. they're, they're also sort of engaging with companies like us.
Why now? What made you say, "Hey, this is my time. This is my, we're going to start this company. We're going to keep it going." And obviously, it was a great time, and you're doing well. But what made you do that?
Well, the answer is sort of very simple to think of. If you went back to 2010, 2009 actually, I was one of the early adopters of a company called App Dynamics, right? They were basically, monitoring Java applications. And I used to write a lot of code in Java back then. App Dynamics came on the back of, 15 years of extremely strong IT deployment. IT systems were being deployed in production. They were becoming mission critical. Therefore, they had to be monitored. I think data systems, data in general turned a leaf in the year 2015, and in the next 3 years, the number of data systems that I saw in production, especially large scale big data systems, I think it turned a leaf in 2015. So between 2015 and 2018, I saw that there was like massive interest and inclination to deploy data intensive applications which are doing things like predictions, recommendation, next best action, etc. And what I felt was that this wave is going to be at least 10 times bigger than the previous wave. So data applications will change the world. There's no doubt about that. And I felt that this opportunity could be at least 10 times as big as the APM opportunity. So that was like the fundamental hypothesis. It almost was undeniable that everybody was trying to become data driven. Everybody had to deal with more complexity. And I knew from the inside that there are not enough people who can deal with this complexity. There's like a severe talent shortage. So you needed visibility, automation, all the good things.
You mentioned you started with a few people, but do you have like a primary partner? Do you have a Steve Wozniak?
It's a very interesting story. So, the glue of the organization, I would say the brains behind the organization, is a really young guy who's about 6, 7 years younger to us, maybe even 8 years younger to us. He's like the brains behind the organization. And, one of the fundamental things that I sort of coalesce on is that, is this a group that I can work together with? And when the four of us, decided to leave, we knew that we could run this band for 10 years. It's about, playing music. That I know how to play drums and you know how to play the guitar, and there's a vocalist and there's somebody else on the keyboard. That's all that you need. And I felt that, we had a good garage band, over here. And, for most of us, actually three of us, this is our 10th year working together. So Ashwin is the Wozniak. He basically says that this is how it'll be done. Then he shows that it'll be done by writing the first set of code and showing the integration and the flows. And finally, he says that, okay, here is how we did it. So it's a rare skill to say what you're going to do and then show how you're going to do it and eventually deliver. So it's interesting. I think we can keep going on for a lot longer in the sense that, we enjoy working with each other.
What's the number one thing you've learned over this process, last 4 years? Number one thing. If you had to just like, I know it could change day to day, but what comes to your mind right now?
It's all about the people. So I define my role as being the service provider for the company, and just making sure that everybody is able to do their best work without interference and without friction. And if I can get that going, every company will work together. When you reduce the friction and when people click together, no technology problem, no market problem, no partnership problem is insurmountable. You will win.
Makes sense. Hey, is there anything that we didn't cover that you'd like to mention?
Well, I think we covered a lot of topics. I think the only thing that we actually did not discuss today is the difference between the DNA market and the AI and ML market. And I've started to come to terms with those two different markets now. And I think, the AI market is going to further necessitate visibility, operability of data systems in a different way, in an altogether fundamentally different way. Because what we're seeing is that, if you're collecting AI data for training, if you're collecting signals for training your models, and if you're trying to look for outcomes over there, that's actually a few times more complicated than just, the DNA market. While most of the customers, if you drew a curve, 90% of the customers are just toying with, ML and AI models, probably deploying 5 models at a time today. That's going to change. That's the next big change that's around the corner.
Well, for AI, statistically speaking, you're better off having more data that's organized, that's clean, that's reliable than not, right? You've got more
And
statistic decisions you can make, right?
absolutely, and non-drifting,
Yes.
consistent,
Quality,
and yeah,
no bias.
no bias. So I think if you don't apply the principles of observability on your entire data set today, then the prediction and outcomes that you're going to get are going to be, radically poor or, ill-fated, I would say.
Very good. Very good. Thank you. Where can folks reach you?
Well, I'm on Twitter at RC Online, and I'm on LinkedIn as Rohit Choudhary. Those are the best places to reach out to me.
In exceldata.com.
Rohit at exceldata.com, .io.
What do you do for fun, Rohit?
I've got 2 boys, I play with them all the time. We
Yeah.
play different kinds of games. I've got a 9-year-old and a 6-year-old. So we do a lot of running around. Unlike, the CEO personality, I'm actually totally with them and
Good to
playing the
hear.
games that they design. It could be sometimes, a simple game which my younger son designed. It's called Catch the Pillow.
Hey, that works, man. That works. Good. You've got inventors in your family. That's terrific.
That is so true.
So thank you for being here. I so greatly appreciate it. Learned a lot today. Learned a lot today.
Thank you so much for having me here. And it was great talking to you as well.
So team, listeners, data systems are just like toddlers. Don't forget it. That's one of the major things we learned today from Rohit Chaudhary. Rohit, thank you very much. Looks like you're going to do well. Looks like Excel Data is going to do extremely well. Already doing well. Listeners, thank you for listening. And until next time, hit us on almartintalksdata@gmail.com. Otherwise, we will see you on the podcast. Thank you. See you all.